in the next section, we are going to see 6 different cards that are being described with 6 different graphs. Our job is to match up each of the situations in the graph. For this section, you have a Desmos card sort that you are going to work on. The link is there in your lesson. But we're going to focus just on one proportional and one non-proportional relationship and answer the following questions. How can you find the slope from a graph? Explain or show your reasoning. Explain what the slope means in the situation. And find the point where the line crosses the vertical axis. What does this point tell you about the situation? In this situation, let's start here with situation A. It's important that we recognize in a word problem, we recognize key information that will help us to determine what the slope is and what some other information is to determine is this proportional or non-proportional. When we talk about situation A, Lynn's dad bought a tablet. That's a good piece of information. He pays the same amount each month. That tells us that he's paying a constant rate. This right here means that this is what his slope is talking about. There's a subscription that he has. The graph represents how much money spent is Y. So Y is the total cost for the tablet and for X months of the service. The slope of the line is 10. That's kind of cool. That tells us something. We already know that the slope is a constant rate. So if he's paying the same amount each month and the slope is 10, then we know that dad is paying $10 per month. So when we go to look for a graph, we're looking for a graph that has that slope of rise 10, run 1. The other thing that we have to look at here that we have to be very careful of for figuring out is this proportional or non-proportional is if this is proportional, that means that dad spent at 0 months, he spent $0. But here's the thing that we also recognize from this. Dad bought a tablet. Because dad bought a tablet, that means that he started out by paying more money at first. So he paid a certain amount of money and then he started paying $10 per month. So we know right now that this one is non-proportional because dad started out by buying a tablet. So he had to start out with some extra money before he actually started paying the monthly subscription. So let's look down here at below at these graphs. We're looking for one that is non-proportional and has a slope of 10. Graph 1, part of our other question said, how can you find the slope from the graph? Well, let's look at the graph and let's think back to what we've done in the past with graphs as we started with, let's just start right over here on the y-axis, or what we call, this is the y-intercept, where the line crosses the y-axis, or a vertical intercept. And we're going to look for these integer points along the graph to be able to help us to determine the slope. In this case, we see that getting from this point to the next point, we have a rise of 5 and a run of 1, giving us a slope that's equal to 5 over 1. We know this is not it because the slope is supposed to be 10. We look at graph number 3, starting here at $40. If this is the case, maybe the tablet was $40. Over here, this would suggest that the tablet is $10. So at $40, we come up to our next spot right here, which is at 2 and 70. So we move from 0.40 to 2 and 70. That has a rise of 30 and a run of 2. That would give me a slope of 30 halves, or 15. And we know that dad did not pay $15 a month. He paid $10 a month. So let's go and check out some more of these. We can't use graph 5 because that passes through the origin, suggesting dad paid $0. Graph 6, same thing. Graph 2 is non-proportional. Graph 4 is proportional. So let's look at graph 2 and just make a final decision here. If we are going to start out here at $40, suggesting that the tablet cost $40, and then we see that we have more points, integer points right here, working our way up. If we rise from the 40, that takes us up $10 a month. Hey, that works. If this is our number of months, and this is our money, we're saying that we're increasing $10, started out at $40 and increased $10 every single month. We know now that for that first situation, graph number 2 matches this situation. We can use this information and we can kind of tell a story now. We know that since we started out with 40, this right here is not only your y-intercept, this is also the cost of the tablet. Because we know that Dad started out by buying the tablet first and then he paid the subscription. So the cost of the tablet, $40 a month, or $40 plus $10 per month. We see that he doesn't have to pay that value for the tablet again, and we continue on. Let's go ahead and look at another situation, and then we'll be done with this section and you can do the rest of it. Situation B, the graph represents the perimeter. So this is a certain distance around any figure, the perimeter y of a square. That's an important piece of information, whose side length is x. The slope is 4. Okay, so now we know that we're looking for a slope of 4, but we're also looking for this. We're looking for a perimeter that has y, that's a certain length, and we're looking for the side lengths of x. What we know about a square is that all of these side lengths are exactly the same length. So it seems reasonable that the perimeter y is the total length of all the sides added together is increased at a rate being compared to the side length. So we could see with this piece right here that this is equal to 4, telling us that the perimeter y is equal to 4 times the length of any side. We can see that this is non-proportional. Think about it for a minute. If we had a perimeter of 0 for our y coordinate, if the perimeter is 0, then that means the side length on every side is 0 as well, because we don't have any kind of measurement. We know that this graph is proportional. And if it's proportional, let's go ahead and match up something with it. We can't use graph 1 or graph 3 because these are not proportional. When we look right here at 40, this is not 0, 0. This is not 0, 0. So let's go ahead and continue to try and find something better. Graph 5, graph 6. Graph 5 we see is proportional. Graph 6 is proportional, so let's test it out real quick. Let's find the slope. Here's a point at 0, 0. Here's a point at 4, 1. And a point at 8, 2. So we see this one as an increase of 1 and an increase of 4. That gives us a slope of 1/4. We're looking for a slope of 4, so graph 5 doesn't work. Let's look at graph 6. We'll start here at 0, 0. We'll follow our way up here. This is 2 or 10, 2.5. I'm going to keep going. Let's see right here. That one's not. Rise 10 over 2.5. That's not very friendly. So I'm going to go to the next one, 20 over 5, which does equal 4. I just found my graph because this is talking about a graph where if I increase by 20 on my y coordinate and I increase by 5, I do get a constant rate of 4. 20 divided by 5 is 4. I know that this is my graph. That tells me that for whatever my perimeter is, that the perimeter is going to be increasing at a constant rate. So if I have a perimeter of 20, that means that each of my sides are 5 units long. So as we look at any of these ordered pairs as we go along here, that could also mean right here with this one, the 10 and 2.5. If I looked at my perimeter of being a total perimeter of 10 units, then each of my side lengths have to be 2.5 units long. So kind of interesting information and cool information that we can learn just by looking at that. Finish off the card sort, and then you're ready to go with the next section.